Welcome to Math with Malia. Today we're covering Savvas enVision Algebra 1, Topic 11, Lesson 1, Analyzing Data Displays. After this lesson, we will be able to organize and understand data using dot plots, histograms, and box plots. And these data representations we have seen in previous grades, possibly starting in 6th grade in elementary school and then working through middle school. So I think we can have a pretty good understanding of this lesson pretty quickly. Example 1, represent and interpret data in a dot plot. Manuel plans to buy a new car with the gas mileage shown. He wants a car that has 26 miles to the gallon. To determine if this gas mileage is good, he gathers data on the estimated city driving fuel efficiency of several other cars. And we can see that data here represented in the table. And we're going to compare the fuel efficiency of the data he collected to his car that he wants to buy. He wants to compare individual values, and so since we're trying to look at individual values, then we need a dot plot that can represent each individual value that we can compare. So to create a dot plot, we have a number line, and we have set the intervals to just count each individual fuel efficiency, starting at 20 and going all the way up to 50. And then each red dot represents one data point. So one car's fuel efficiency that he researched. And you can see we have a total of 16 dots. So he had a total of 16 cars that he researched. You can see that we stack the dots on top of each other. So we have 4 cars that had a fuel efficiency of 26. We had 2 cars that had a fuel efficiency of 27, and so on and so on. We see we have this outlier here at 45 miles a gallon. It's called an outlier because it lies outside the normal data set where all of the other data points are. And we're going to learn in future lessons what an outlier actually does to affect our statistical analysis. So this dot plot shows that most of the values in his research are clustered right here. We can see they're all grouped together between 25 and 28 miles per gallon. And the car that Manuel wants to buy is 26 miles per gallon, which fits right in this cluster. So it is comparable to other cars that he has researched. What could account for this outlier? What kind of car might have a fuel efficiency of 45 miles a gallon? Well, if we think of modern cars now, probably some kind of hybrid car. It's still using gas mileage, but as it's a hybrid, it can have a higher miles per gallon fuel efficiency. Example 2, looking at histograms. Histograms are another way that we can represent statistical data. A marketing team is about to launch a campaign for a new product that is targeted at adults aged 25 through 34 years. The team is researching the age range of viewers of a certain TV show to decide whether to advertise during the show. The data show that the ages of a random sample of 30 viewers of the show. So they've surveyed 30 viewers and they tabulated their ages. Based on the findings, should the marketing team launch their campaign during this show? So should they run their commercial during this show? So you can see in the table, we have all of the individual ages of the 30 viewers they surveyed. We have a 14-year-old, 25-year-old, 14-year-old, 37-year-old. So we have quite a range of ages. And as we're looking at different age ranges, a histogram is used because we can set our input values as an interval. So you can see here in our table, we've set an age range of every 5 years, going from 0 to 4 years, from 5 to 9 years, from 10 to 14, and so on, all the way up to 44 years. So first, to create a histogram, we want to fill out our frequency table. So as we've established our intervals, our age ranges, now we're going to just count from our data set each individual age and put a tally mark in the interval that it falls under. So 14 would fall under the 10 to 14, and we'd put a tally mark there. And we continue inputting every data point from our survey and look at the results in our frequency table. So we can see that we don't have any viewers that were young children. We have a lot of viewers that were in the age ranges of 15 to 19 and 20 to 24. Okay. If their target audience is 25 to 34 years, this right here, well, they don't have as many viewers. Here we had 20 viewers in the younger age range, and here we only have 7 viewers in their target audience. So is it a good idea to run their campaign during this show that has their target audience of only 7 viewers? Probably not. So now we can create a histogram from that frequency table. We set up our x-axis with our interval ranges, so you can see each of the intervals there, and then our frequency is just the number of tally marks on our y-axis. And we make a bar graph. With histograms, since we're representing interval ranges, it's important that our intervals do not overlap and that our bar graph touches each other. So we can look at trends based on this histogram bar graph. You can see that if I were to draw kind of a curve, we have a peak here at our age ranges of 15 to 24. So here's our peak. This is where most of the data falls. Their target audience is here. And again, we only have a total of 7 viewers out of 30. If we do 7 divided by 30, that's about a 23% of their viewership for this show. That's less than 25% of the viewers watch this show. And so it would not be a good idea to run their campaign because they wouldn't hit their target audience very much. What would be a better age range for them to target for this show? Well, probably this peak right here from ages 15 to 24. That would be a better target audience for this particular show, as that is the majority of those viewers. We can see we have a total of 20 viewers out of 30. That's 2 out of 3, or about 67% of the viewers are in that age range. So for the try it, again, we should target ages 15 to 24 with 67% of the viewership falling in that age range. Example 3, representing and interpreting data in a box plot. Students at a local high school organized a fundraiser for charity. Caitlin, the student council president, announces that more than half of the students raised over $50 each. So she's making this claim, more than half. So we're talking about like percentages of total data. The amounts of money raised by a random sample of 24 students is shown. So here's her data. Here's the amounts that each of the 24 students have donated. She claims that the distribution is over 50. Most of the donations were over 50, and we can use a dot plot to actually analyze if her claim is correct. So a box plot is important because it shows distribution by using a 5-number summary, and these are the 5 points that we get from a box plot. We know first the minimum value. We know also the maximum value. We know the median, or the middle point of the data, and we know the first quartile, and we know the third quartile, which is our 5th point in our 5-number summary. So what do those things mean? Well, the minimum obviously is the least value in the set. The maximum is the greatest value in the set. The median, again, is the middle as we order the data sets from least to greatest. The first quartile represents the middle of the first half, okay, of our data set. So after we found the median, then we find the middle of the first half, the lower half, and the third quartile represents the median of the upper half from the median to the maximum value. So let's take our data and order our data points from least to greatest. So we started with 25, and we're going to write each individual number in order from least to greatest, including repeats. Then to find the median, since I have a total of 24 students, I'm just going to divide the total into half because the median splits the data in half. Well, what's half of 24? That is 12 students. So if I'm counting from the minimum, 12 students from the least number should get me right here. I should have 12 data points to the left of the median and 12 data points to the right. I'm splitting the data exactly in half. So the median would be at 45. The minimum we already said was at 25, and the greatest value was at 68. Now we're going to find the median of the first half, or the lower half, to find quartile 1. Again, now this is 12 data points, so I'm going to find the median of 12. That means I'm going to count 6 from the first one, 1, 2, 3, 4, 5, 6, and I should have 6 data points to the left of my first quartile and 6 data points to the right of my first quartile. And to find quartile 3, we do the same. Calculate the median of the upper half of our data set. Again, the upper half is 12 data points, so what's half of 12? Well, we should have 6 data points to the left of quartile 3 and 6 data points to the right of quartile 3. So now that we have our 5 key points in our summary identified, we can make our box plot. To make a box plot, again, we're going to create a number line. So we create a number line, and it represents dollars raised. Then we're going to plot our minimum and our maximum. So plot your minimum and maximum values. They're going to be represented by dots. They're the endpoints of our box plot. Then you can graph or plot the median. So we know the median is the middle of our data, so you'll plot the median there as a vertical line. Then we're going to plot quartile 1 as another vertical line at its value, and we'll plot quartile 3 as another vertical line at its value. And then we close our box. We connect the top and bottom of the quartile 1, median, and quartile 3, and that is our box. That is called the interquartile range, or IQR. It's the interquartile, meaning the middle quartiles. Why do we say quartile? Well, quartile sounds like quarter. Each of these sections represents 25% of the data. So from the minimum to the beginning of the box to quartile 1 is 25% of the data. From quartile 1 to the median is another 25%. From the median to quartile 3 is another 25%. And from the end of the box, or quartile 3, to the maximum is our last 25%. So the interquartile, or the middle quartile, the middle quarters, that range is just really the distance from the beginning of the box to the end of the box. And we're going to talk about what that means in the next lesson. From our box plot, we can see that the median or middle amount that was donated was 45. Looking at our percentages, if I'm looking at half of the data, that means from the median. So the median divides my data into 50% to the left and 50% to the right. Caitlin said that 50% donated at least $50. Well, that's not true, because 50% here was only over $45. So her claim is not supported by the data. What can she say? If she wanted to say 25% of the donors donated at least this amount, what could she say? Well, again, 25% of the data is right here. The upper 25% was at least what value? Well, the end of quartile 3 was at 52. So we could say that at least 25% from quartile 3 donated $52. So she could make that claim, and that would be supported by the data. Example 4, choosing which data display to use. It depends on what you want to analyze. Helena's dance team scores 68 points at a competition, and you can see the scores here in the table of all of the other teams in the competition. She wants to know what place her team finished. Should she use a dot plot, a histogram, or a box plot to display the data? Well, what are the values of each of the displays? A dot plot is excellent for showing clusters where they're all grouped together and for identifying outliers, data points that are way outside of the norm. Histograms group into ranges or intervals. So we are not seeing individual data points, but we're seeing frequency that fall in each interval. So we can see trends from a histogram, like where the peak is, or if it's symmetrical. A box plot is used because we can see the spread of data, or in other words, the variability. How spread out is the data, or how close together is the data. We can also look at where the center is, or the median. A box plot does not show individual data, but it does talk about those 5 key pieces of information, and we can look at percentages of data. If Helena is interested in displaying individual scores, well, Individual scores are not shown in box plots, not shown in histograms, because that's just frequency in each interval. So she's going to want to show a dot plot to represent individual scores. What if she wanted to compare the median with other teams? Well, we see the median in a histogram, and we also see it in a box plot. It's very clear in a box plot, so she could use either of those. So here's the dot plot that represents the scores of all of the teams that competed, and Helena's team scored 68 right here. We can see that there's a cluster of scores up here between 79 and 83, and we do see a big range. The minimum score was 65 and the highest score was 90. According to this dot plot, what place did Helena score on her team? Well, there were a total of 16 teams, and there were only 3 teams that scored lower than her team. So if this was the 16th place, 15th place, 14th place, Helena's team scored 13th out of 16. Which data display should she use if she wants to know what percentage of the team scored higher than her team? Well, remember, if we use our box plots, we can see percentages. Each section of the box plot represents 25% of the data. So she would want to use a box plot if she wants to see what percentage of teams scored higher than hers. All right, we made it to the concept summary. Make sure to leave any questions in the comments and be sure to come back for lesson 2.